So today I'm going to be talking about Spring Web, the 4.x generation, which is basically the last 1 or 2 years. My goal is to try and take you through some of the stuff that's been going on in that time period. So rather than present only the latest, basically give a little bit more context. And you know, I think some of the things that we'll talk about may be things that you've seen, but hopefully there is something there that will catch your interest that you can take home with you. So before we get started, I just want to ask how many, well, I assume everybody is doing some kind of web development, but let's see a show of hands for that. Okay, if you're doing Spring MVC or have Spring MVC application, okay, most. Anybody not on Spring Framework 4 hasn't upgraded yet, 3.2. Okay, I assume 3.2? Okay, yeah, that's 3.1 is no longer supported, so hopefully you're on 3.2 at least. Yeah, so basically that's what we're going to talk about. A little bit about me. I am a Spring Framework committer. I focus on Spring MVC and also on the WebSocket side and messaging. You can see my commit history starts around 2011. That's pretty much when I joined the team to work on Spring MVC. That's what I've been focusing on. And I pretty much lead the design and the changes that happen in the framework on the website. Of course, I'm not the only team member, but this is my primary area of focus. So first of all, just a little bit of retrospective. So Spring MVC was there with the Spring Framework from the very beginning, going back to 2003. And if you think about it, that's around the time of JDK 1.4, which means that we did not have Java annotations. The whole REST versus SOAP debate was still yet to take place. Single page apps, none of that was there, which means that the framework looked very differently in the beginning. And in order for a framework to remain successful over such a long period of time, you really have to evolve. And it's interesting trying to achieve that while you maintain backwards compatibility. But it's fair to say that the framework has done really well, and while initially the popularity is to some degree thanks to the fact that the Spring Framework became very popular, so kind of riding the success of the Spring Framework, today Spring MVC continues to enjoy a most popular status in the Java web framework space. And I don't think this is an accident. So just taking a look at some of the major points in the evolution. So in version 2.5 of the framework around 2007 is when we had Java 5 and annotations. That's the first time that we have the annotated controllers, which is probably what everybody's using today. But there was a point in time when that wasn't the way that you would write Spring MVC applications. So that's a major change in the framework, in the programming model. Of course, it was adopted very quickly, and it's widely used today. In version 3, that annotation support was basically continued in order to provide complete REST support, kind of more complete in a variety of ways, the path variable and lots of other things. And it continues to evolve ever since. And then more recently, we have support for things like asynchronous requests, for WebSocket style messaging, which really brings us into more present day single page apps that where the server and the client both need to be able to talk to each other. We'll cover that a little bit as well. So what are some of the keys for a framework like Spring MVC to be successful over a long period of time? Well, first of all, at the core of the framework, we have a very simple and clean design, which survives the test of time. So if you're familiar with the handler mapping, handler adapter, the view resolver, these are the basic contracts which have remained unchanged, and they're well understood. And even though on top of that we've done lots of things with annotations, with more opinionated style of doing things, the very core remains fundamentally the same. That's been a great bridge between the pre-annotations versus post-annotations. For example, there's still applications today that probably go back to before we had annotations. I think recently on a blog post, somebody was asking a question about moving from Spring Framework 1 to Spring Framework 4, which is a bit of an extreme case, but obviously that is what happens when we write software. Often it's not necessary to rewrite it every day. So if you're on 3.2, you must be feeling good. Somebody is on version 1. It's been friendly to extension from the very start. It's very extensible, and I think this is very important also for third-party frameworks, because there's plenty of cloud solutions and frameworks and not only applications that build on Spring MVC. It embraces HTTP and REST. You might say, what does that actually mean? But there are other approaches, like if you think about the JSF approach, for example, that basically goes in the other direction. It basically says HTTP is there, but really we're going to make it look like desktop application development. We think that's an easier route to go. And I understand the lure of that. It basically means that with very little investment in knowing HTTP and JavaScript, and that's a very confusing landscape, you can produce stuff. But in the long run, staying close to HTTP and REST really helps to stay with the times, because I think it's clear that everything is moving towards single-page apps with RESTful backends and a more clear separation between what the backend does and what the front end does. So I think in the long run, this has been really helpful. Also, around version 3, when we talk about REST, there was a decision at some point to make, do we create a separate REST framework? And I think the conclusion at the time was that Spring Web and web in general, there's no need to artificially separate what we do for browsers versus what we do for RESTful services. And that's been another one of those choices that's been validated in the long run. I mean, if you see now, there's an MVC spec in Java EE, which basically goes in exactly the same direction. It's built on top of JAX-RS. And last but not least, the community is really the biggest key to the success of Spring MVC, because we have continuously a lot of requests from real applications that are really driving in a major way the direction of the framework. I think this is definitely one of the very defining things about Spring MVC, is that there's a lot of gaps and a lot of things that get filled in through very solid requests from the community, and that's really something that's hard to overstate. So the web and Spring MVC, not surprisingly, is one of the most actively developed parts of the Spring framework. You know, where with some areas of development you basically reach a point of maturity and there's not much else to provide. With Spring MVC and the web, it's always moving, it's always something happening. We are not only getting continuous flow of ideas where people put the features to use and then they come back and say, well, this is really what would make sense as well, and we added, but there's also more major features and even modules that are trying to keep up basically with new trends. WebSocket is a good example of that. So there's always stuff happening in the web, and the framework is very actively evolving. So let's take a look now, after this intro, at Spring MVC and some of the way that the programming model has evolved and some of the newer features. Well, this is something that probably everybody's familiar with. This is what we call @MVC, or the annotated programming model for Spring MVC. Basically, we have the request mapping annotation that indicates how a method is mapped to HTTP requests. And in addition to that, we have these auxiliary methods for initializing data binding, for preparing model attributes, and also for handling exceptions. And recently we have also the REST controller, if you hadn't seen that. Basically that's a very similar component stereotype, similar to the @controller. which basically says this controller is going to be focused primarily on REST API, which automatically means that response body is kind of an assumed annotation. You don't have to put that on every method. So now the return value, instead of being treated as something to be added to the model or as a view name, it's always treated as something to be serialized to the body of the response. So this is basically our REST side of things, REST API. Now, the controller hierarchy is great, and you can do a lot with that, but sometimes there's a need to go across controller hierarchies. And where this request originated from is somebody came and said, I'd like to see global exception handler methods, annotated methods. And that makes a lot of sense, because if you are handling something like a file not found exception, it doesn't matter what controller it's coming from. It's natural to want to have a global version of that. And you might wonder, well, why is that in the first place controller specific? Well, these annotations evolved from that, basically for being on a specific controller. So you can put your exception handler in a base class. You can do a lot with that, but it's also useful. There's a lot to be said about going across controller hierarchies. So that's where we basically thought about this and said, well, this actually could be much more general than just exception handlers. We're going to call that controller advice. And you can put in that any of the auxiliary methods that normally would go in a controller, and they would apply by default globally. And there are different kinds of selectors that you can put on that. So by default, like I said, it applies to every controller. And all you have to do is just declare this thing in your Spring configuration, and it's automatically discovered. But you can also scope it to specific packages. So you can say this controller advice is going to apply to this particular submodule or to any class which is annotated with REST controller, or even down to specific types. You can do that as well. And by the way, at any time, if you'd like to ask a question, feel free to do that. A specific example of a controller advice, something that we provide in the framework. I don't think many have seen this class, because I see this being implemented in different blog posts, for example. So very often when you create a REST API, a good practice is to produce good error details. So in the body of the response, not only send a status like a 404 or 405, whatever it may be, but you also want to include some JSON, for example, in the body of the response in order to indicate, like give a API error code or a detailed message and things like that. And that's not something that we can build into the framework automatically, because what's in the body of the response, each REST API is going to differ a little bit, even though conceptually it's very similar. But we can't automatically put that in the framework, unfortunately. But we do have a base class called ResponseEntityExceptionHandler. And you're probably familiar with ResponseEntity. It's basically a type that we use for writing to the body of the response. So this base class automatically handles Spring MVC exceptions, but it stops short of actually filling in the body of the response. So that's the part that you have to do, but it kind of goes 80–90% of the way, and you just have to provide the rest of it. And you can use that as a starting point, and you can also add more exception handler methods to it for your own errors that are coming from your application. Now, the controller advice can actually be used, so this is an example of a base class that you can implement, and then you're kind of expected to put controller advice on that, and that helps you to make it applicable across. But there's also something else we've added recently, which is called response body advice. And the need for that can be explained. So we've had a lot of requests where applications want to be able to do something with the response interception style just before the response is written. I think probably everybody knows the handler interceptor. You can use that in Spring MVC, but the post handle method, it's too late to do anything if you have like a response body method. So if you're doing a REST API using a handler interceptor in the post handle is too late because at that point we've already written the response. What you really want is you want to hook in to the writing of the response before it's actually written out with a message converter. And an example of that might be, let's say you're trying to, I think one particular request was around a third-party library that was adding Google search related headers to the response. So basically wants to take a look at what does the controller method actually do, and then depending on that, look at the headers on the method and add some search optimization SEO related headers to the response. But again, post handle is too late at that point. Question?
I actually just thought of the great reason to use this is if you are outputting HTML and you want to format it, pre-formatting for when you're looking at the source in a browser.
Okay.
You can run it through like a HTML lint or something like that, HTML tidy.
Okay, so the suggestion is to take the HTML output and rewrite it, reformat it.
And new lines and stuff like that that you normally would do.
Yeah.
Make it pretty.
Yeah, you could probably. Yeah, I mean, at this level, you won't have really access to the HTML necessarily because the controller would return a model attribute or a view name. So the HTML rendering is still to take place. But where this is really interesting is actually to REST controllers, something that's doing REST API because again, if you consider what REST controllers do versus browser-oriented controllers, the browser-oriented controller is going to return a view name, and then you're going to go through the view resolution, pick an HTML template, and then do the rendering. Whereas with REST controllers, you return like an account object, and then a message converter, like the JSON converter, is going to serialize that to the response immediately. It's kind of more of a short circuit, it gets handled all within the controller, so at that point using an interceptor is too late. But we do have a couple of built-in examples of where this is useful. In fact, these are features that are now supported. So JSON view, how many know about the JSON view annotation? Okay, how many are using JSON? Okay, so JSON has this annotation called JSON view. And I won't show any examples of using that, but the idea is that if you are returning an object that has a lot of fields, then on some pages you might want all of that. On some pages you might want a subset of that. So if you're showing a detailed page versus a listing page of accounts, on the listing page you might want to show a little bit of every account, just the account name maybe and the account ID. You don't want to have the whole account detail. So the JSON view allows you to define specific fields and associate them with some sort of a name, like a serialization view, so that then on specific request mapping methods you can say, this time I want this view of the account object, that time I want that view. So it's basically a mechanism for rendering a subset of an object instead of the entire object. So the way that this is supported now in Spring MVC is you can put the JSON view annotation on a request mapping method, and then you can specify a serialization view by name, and that's going to end up rendering a subset of the data and not the full data. And this is done with a controller advice, a response body advice, in fact, which basically right before serializing looks whether the method has a JSON view annotation or not and does the right thing. Same thing for JSON-P. So JSON-P is basically effectively just decorates the response with a JavaScript function. And again, that we do with the response body advice. Yeah, so the original request was once again for some sort of an interception hook, but as soon as we thought of it and added it, we found immediately two other things we were working on. Suddenly it's like, hey, we can do that using this, and that was a great realization. So clearly a useful extension point. Now, speaking of JSON, we have some improvements in this area. So you can now use JSON for both serialization of JSON and XML. I'm not sure if you're aware of that as an option, but basically it's now supported. And this is nice because if you're using the JSON view annotations, essentially that means you can do that with JSON and with XML. So that's a great benefit right there. We have a builder that we provide to prepare an object mapper. So we find that in general that object mapper customizations are very, very common when you're doing JSON, when you're using JSON, and being able to prepare it with a dedicated builder is actually extremely nice because first of all it gives you focused methods, but also what you can do is you can create one of these object mapper builders, and that encapsulates some kind of logic for customizing an object mapper in a specific way, and then you can reuse that builder. So you can use it for your JSON, you can use it for your XML. It becomes much more than a convenience. It becomes a way to encapsulate customizations for an object mapper. There is a blog post that I highly recommend reading, which summarizes all the JSON improvements. You will get a link to this presentation. Basically, I have the slides on SlideShare. If you look for Spring 4 web apps, there used to be a version of it that I gave half a year ago, but the most recent slides, which I've redone for this conference, updated, that's what should be there now. So if you find that on SlideShare, you'll get all the links. Now, a few things around request mapping methods. First of all, with Java 1.8, anybody on Java 1.8? Okay, a couple of lucky people, lucky souls. So JDK 1.8 has this type called java.util.Optional, and that allows you to represent something which may or may not be available. So instead of checking for null, you use this optional type. What's interesting in Spring MVC, in the context of Spring MVC, is that when you have an annotation like request param with required equals true or false, this is a great combination because you don't have to say required equals false anymore. You just declare optional as the type that you want to take into the method, and that automatically tells us explicitly that you mean required equals false. So we can automatically do the right thing. So that means you can just do request param, optional, whatever the type is, and that automatically means required is false. We support listenable future as a return value. That's basically the same as returning a deferred result. And we'll talk about that in a little bit. We have response entity and request entity builders. So this is really nice because it's very commonly used in controllers. I'll show that shortly. We have the ability to prepare links to annotated methods. Again, this is something that's been requested for a long time. So let's take a look at some of these things. First of all, for response entity builder, I mean, clearly the number of lines says it all. This is something that commonly happens in Spring MVC methods. You're returning a response entity, and while it's very straightforward, invoking a constructor and passing the body, the headers, and the status, what's nice about the builder is not only that it shortens the syntax, but it also allows us to provide recipes that focus on the most common cases of the kinds of things that you do when you're responding. For example, sending back a 201, sending back a 404. Like, we can model these things around the kinds of things that are typically done. And also, if you think about HTTP headers, it's a type which has both client and server-side headers. But when you use the response entity builder, that's actually helping you to focus only on headers which are relevant to the server side. So all in all, it's actually a great thing to have. Same thing for the client side. So if you're using the REST template, you would prepare an HTTP entity and then pass it in. Now we have a request entity builder, which again focuses on a subset of what makes sense on the client side. So if you're doing client side, that's pretty nice. Now, in terms of links to request mapping methods, so the motivation for that should be relatively clear. Basically, we have request mapping methods in our controllers, and we want to be able to clearly redirect. We want to be able to link to those methods. But we already have the request mapping annotations containing metadata. They contain things like HTTP method, they contain things like a URI template. If we redirect, we don't want to replicate all that metadata. We don't want to repeat the URL. We just want to be able to point to a particular method, and we should know how to prepare a link. And that's really the idea behind this. And the way that it's done is through a simulated controller method invocation. What that means, how many are familiar with something like Mockito? Or there's other libraries that use a similar technique, basically mock objects. Basically, you just you tell it the interface or the class name, and it creates a proxy. And then when you use that proxy, it actually does something other than invoke the actual class. So basically, this is what's happening here. We're providing a way to invoke a method that on myController.class is a bit like creating a mock in Mockito. And then when you invoke the method getAddress and pass a parameter, it's not actually obviously calling the controller class. Instead, it's preparing a link to that controller method and gives you back a URI components builder that you can then further work with. And there's a section in the documentation that talks about this. You can take a look in more detail. Also, we want to be able to do the same thing from HTML templates. We want to be able to prepare forms, and we want those forms to point to annotated methods, but we don't want to replicate in all our JSPs or timely templates or whatever. We don't want to replicate all the mappings. So basically what we do for that is that we allow you to refer to a request mapping method by name, and that's a name for the mapping itself. And the way we do that is we assign a default name to every request mapping. How many of you are familiar in an IDE? You can type just the capital letters of the class name, and that will bring it up, right? Or then if you do the hash sign and then type the method name, that will bring up, it'll take you directly to the method. So basically that's the default strategy, and it's easy to remember that way. You can refer to mappings by name that way. But you can also give an explicit name to a request mapping annotation, and then you can refer to that from your views. Again, there's a section for that in the documentation. If you have a lot of model attribute methods, sometimes you might get into a situation like this. You have one of them create one object, another one create another object, and you want them to be invoked in the right order because they have that kind of dependency. The first one is adding foo to the model. The second one is actually taking foo in as a method parameter in order to do something with that, and then maybe optionally add bar. So that sort of thing apparently shows up, comes up a few times, and we've added support to make sure that these methods are invoked in the right order. Interesting little fact, this was never an issue for a long time because the way that Java would do reflection, when you say get me all the methods in a class, Java would do that in the order in which the methods are declared. So I think that's what implicitly a lot of applications relied on for a long time. Then JDK 1.7 comes along and changes that, and suddenly it's a problem for a lot of applications that relied on it. So this is how this feature came about, essentially. This way we give a more deterministic order for the invocation of model attribute methods. So this next one is actually a pretty big topic for web applications. If you are writing web applications today, you're certainly dealing with static resources. And as you know, well, I'm talking about things like JavaScript files, CSS files, fonts, and so on. And in order to be effective, I think I remember seeing some kind of statistics that the average application today has about 50 to 100. I think it might be closer to 100 links embedded within a single page, which means that when you hit some page, on the average you get about 80 or 90 additional requests, which is really bad on a mobile phone, for example, for every one of these requests to go out and get DNS resolution, etc. So the idea is that you want to try and optimize on that by minifying, first of all, files to reduce their size, to concatenate them to reduce the number of files that need to be downloaded, And there are some things coming in HTTP 2 for that, for pushing resources, but it's going to take a little while before that happens. And it's going to be interesting to see how that impacts the whole discussion. You know, if you look at what HTTP does, they would basically say that all of these optimizations are hacks. But these are hacks that we have to do today in order to make applications perform better. The reason why they're called hacks sometimes is because their net effect is not always positive, right? You end up then downloading something concatenates everything and you download it on every page. So that can be, if you don't have the caching header set right, that can be a problem. Or even if you have the caching set right, then if one of your files changes, now you have to re-download the whole thing. So, you know, the net effect, it's not always clear that they're positive, but nevertheless, we can't ignore this topic and we have to try to optimize. But then the questions begin. How do you actually do that? Do you do that on the client side using JavaScript tooling like Gulp and Grunt? Anybody using Gulp or Grunt or JavaScript tooling? Yeah. So you can do all of that using the way that a JavaScript node application would do. Or you can do it on the server side using plugins in Maven or Gradle. Anybody doing that? Optimizations. So these are additional options. Then you have to worry about HTTP caching and versioning URLs, using CDN, production versus dev. So this is a big topic for web applications. So what we decided to do, as you probably know, we have a resource HTTP request handler in Spring MVC. And that's just a simple mechanism that lets you serve files from anywhere, from the class path, from jars, from under the web INF, from the web app root. And it was just very straightforward serving of files plus a few HTTP caching headers, things like that. What we've done in 4.0 is we've expanded that with abstractions to do generic resolution and transformation of resources. An example of that might be taking a less file, transforming it into a CSS file as the request comes in. That's one example of that. And as part of that, you also need to prepare a public resource URL. So when you're about to render a link to a JavaScript file or a CSS file, you need to decide what that link should look like, because it's not necessarily the same as the path. And here's sort of the classic example of that. If you haven't heard of this term, URL fingerprinting, well, HTTP cache busting is another term. But essentially what it is the problem on a simplest level is this. If you're serving a CSS file or an image, you can attach some caching headers to that, like max age, to make sure that the browser doesn't ask for it again next time you ask for the page. Problem is, how long should these cache headers point to? Should they come back and ask for it again in 2 months, in 2 weeks, in a year? That's kind of the challenge there. You want to achieve it's hard to achieve a balance between freshness and staying optimal. So what HTTP caching does is it puts a version in the URL of the CSS file, for example, like you see here. And that version will change when the content of the file changes. So what this allows you to do is you can put aggressive cache headers, something like max age equals to a year from now, which means that for a year, browsers and proxies will not ask for this CSS file again, which is great. It means that your page will now load very fast the second time. And the reason why you can do that is because as soon as the content of the file changes, the version changes, and now you're re-obtaining the file once again. So this is a feature which is now built in with the resource handling that you can get automatically. That version is calculated from the content of the file. So if you're familiar with the way Git, for example, calculates hashes and then uses that for comparing to see if two versions are the same. Same thing we do here. And you might already be wondering, well, that's expensive. You know, we can't do that every time we render a link. And that's correct. That's the first thing we found out. And basically, we have a caching. So I talked about having a resolver and transformer chain. In the beginning of that chain, if you're in development, you automatically get a caching resolver and a caching transformer, which means that as soon as we resolve this once for the first user, the result gets cached so that subsequent requests you don't have to recalculate. And as a developer, you can for example, in production, you can have this cache, you would want to, and you can basically either clear it at runtime, or if you restart the server, it basically automatically starts with a fresh, with an empty cache, so it has to fill it. But you get the idea for this feature. And this is a very expensive topic. I mean, if this is something that you deal with in your project, I highly recommend watching this talk that we gave at Spring 1, along with slides and source code. I'll just mention a couple of things. First of all, here in this talk, we discuss at length the whole landscape, kind of trying to choose between using gulp and grunt and doing your optimizations client-side with npm-driven build versus doing that in your Java Maven build, integrating it. We talk about the tools that are available for doing optimization, concatenation, and things like that. And in the context of that, we talk about the new features in Spring MVC and how you can combine those two things. And I'm not sure how many of you are aware of Spring.io, the website that we have, which is actually written with Spring technologies. It's a project called Sagan, which is open source. And that's using a lot of these resource handling features. And we could have pointed to that source code, but it's a little more than what you can digest just for this particular issue. So we created a sample which is self-contained, and it's much easier to look at, and that's what this source code is. So if this is a topic that is important to you, definitely check it out. How many JSP users? Okay. What else? Time leaf? Anybody using time leaf? What's everyone else doing? Just pure REST? Yeah. Any other templating? FreeMarker? Any FreeMarker? Yeah, so this space has been kind of an area in which there's been very little innovation in Java for a long time. We've had JSPs, which from the start nobody really likes and nobody really likes to recommend. It's, templating should never let you do anything you can do in Java. That's kind of goes against many rules. But at the same time, we've been lacking modern options. FreeMarker and Velocity are okay, but they're really, at this point, more of templating technologies, not necessarily a whole lot of features for HTML. We have TimeLeaf, and TimeLeaf is a great alternative to JSPs because it's very complete, and there's a lot of good things about it. For example, you can render the templates without the server, and it does a reasonable job of showing you default content. What's interesting here, with Groovy 2.3, there is a markup, HTML markup templating engine. And as you can see here from the syntax, it's basically a DSL for HTML. If anybody's heard about Haml in Ruby on Rails, you may have come across that. It's basically a similar concept. Instead of spelling out the tags, like opening and closing tag, basically you just say HTML or head, and that fills in the details for you. So there's a lot that can be done there. Kind of really shrinks the HTML, so you have a lot less in the template, makes it more readable. And it's easy for designers too, because they can learn the syntax fairly quickly. It's not like something you're asking them to learn something new. So that's why we say this is dry markup, and I think this is a very interesting option to have, and we added support for it, so there's a view resolver in Spring MVC for that now. So if you happen to be using Groovy already in your application for any reason, then this is a no-brainer, trying this out. On the side of the MVC config, we have a few changes. We now have a view resolver registry, so if you're configuring view resolution, that's now available in the Java config and XML namespace. The view controllers, if you're familiar with those, they can do a lot more. You can do redirects, you can set the status codes, etc. And we have path matching, which is a very common thing that, that people ask for, that we've added explicitly configuration options for that. Okay, so we come to a topic which is still within web, but not necessarily Spring MVC entirely. We'll start with this. How many of you are doing some sort of async requests in the web space, like long polling or HTTP streaming? See a couple of hands. Okay, well, this is something that's been available since Spring MVC 3.2. It's based on Servlet 3 capability. What it is well, to explain the problem, essentially, the problem space is you have something like a Twitter app or a chat. A chat is better because chat is something that is sensitive to real time. Most retail websites now have some sort of a chat option with customer service. And clearly, when there is a new message, you want to see that right away. But as you know, in HTTP, the challenge is that the server cannot write to the client. The client has to start a request, and then the server responds. So the technique that's evolved over time is that what we call long polling. So a simple way to do it is you can poll very quickly. The client can constantly say, any new chat messages, any new chat messages, and the server is constantly saying no, 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 suddenly yes, and you can make that work in this way. In fact, if you take a look at what's going on with the browser, if you kind of peek, as developers often do when you're chatting for your order, you can see that that's what's happening. There's a lot of HTTP requests, and many times it's just straight polling. But you can do better with long polling. Basically, what long polling does is you send a request just like polling, and the server doesn't have any chat messages for you. So the server will say, all right, I don't have any chat messages, but I'm going to park this request, and I'm going to respond to it when a chat message actually becomes available. Basically, there is explicit support for that in Servlet 3. By indicating that you're starting an asynchronous request, you say request dot start async, I think. I don't remember the exact name. But it basically tells the container that this request should not be completed. And then you exit out of your class. You exit the processing of the request all the way. But the server knows not to close the response, and you can keep writing to the response. That's kind of the idea. So basically, the server now will wait until there's something. Typically, we're talking 30 seconds, 60 seconds. Anything longer than that, the proxy might kill the request. So you want to keep it down to about 30, 60 seconds, which is still a very long time for a request. But it allows the server, so if you think about polling frequently, instead of doing a request every 5 seconds, if there's no chat message for a minute, server can hold on to that for a minute and then send you back a chat message as soon as it's available. So that's the idea, doing server-side push. Yeah, so basically, how do you actually do it? If you're using the Servlet 3 API directly, yeah, you would be doing these kinds of callbacks, or you basically just hold on to the response and keep writing to it. But we've added first-class support in Spring MVC. We've had it since 3.2. And it's basically as simple as returning a deferred result type instead of the actual result. And then when you're ready, just call set result, and then everything continues from there. So we've made it very simple. And that's the next point, is that by doing this, you can implement a chat client with what you know. It's REST and HTTP. It's kind of bending HTTP in many ways, but for such things, it can be done and the server supports it. Where it gets more difficult is when you talk about advanced use cases. So if you think about implementing an online game, if you think about a financial application or some kind of collaboration app, which are now very common over the web, it's actually, at this point, very complicated to try to do this long polling thing. The other thing is that if you're doing long polling, if you think about it, if there are a lot of chat messages all the time, it's no longer long polling. It becomes very short polling, right? Because as soon as there's a chat message, you have to send it. So there are limitations to what you can do with long polling and HTTP streaming and all that.
How will that different from the HTTP2 server push?
So the question is about the HTTP2 server push. So the idea behind HTTP2 server push is to be able to, because the server in many ways can anticipate all the 60 or 80 or 100 resources that are part of that page. Let's say you go to the home page of your app, you already know what the JavaScript should be, what the CSS should be. So what you can do at that point, you can, from the server, you can push all those resources to the client. So it's a little different. It's not a replacement for something like WebSocket or two-way communication.
Yeah, I understand. I'm just saying, if the way to make it easier for the server, the implementation to take advantage of the server push.
Yeah, probably not, is my guess. Although at this point it's still relatively early to tell, because when I follow some of the HTTP2 stuff, I see a bit of a disconnect between what server implementers are thinking about and the way they view it versus the way that the browser and the client side, they seem to be a little bit not on the same page as to what this actually means. So it'll be interesting to see. It's basically moves responsibility to the server to decide what to push to the client in terms of resources, but the client is still in the best position to know what should be loaded first. Should it be this JavaScript file or that image in order to effectively load the page? So it's going to have to be that the server starts pushing and the client then has to say, no, give me that one first, not this one. So how that's going to work out, I'm not too sure yet. But whether that even extends to these kinds of use cases, I'm not sure that it was intended for them. Maybe, I mean, long polling is not what HTTP was intended for, so maybe we'll still use it, but I think it's early to tell. The point is that we do have something for doing that, and that's the WebSocket protocol. And the WebSocket protocol is basically bidirectional messaging between client and server in web, specifically for web applications. And in Spring, we have support for that. First of all, we have fallback options, because as soon as you use WebSocket, you have to deal with the fact that WebSocket is not available in Internet Explorer less than 10, which automatically means if you have any kind of public-facing app, it's really not a practical proposition. Further, you have proxy issues, because proxies are configured for HTTP 1, and they don't understand why a connection continues for so long. Or they look at the traffic on it and they don't think it's HTTP, so they shut it down. So what's often recommended is to use the encrypted version, WSS, which prevents proxies from actually understanding what's in the messages. At least they don't try to shut it because they don't understand it. But you still need fallback options because, again, just for IE alone, you need that. Also, we have support for STOMP, which is a sub-protocol in WebSockets. A sub-protocol means basically a protocol running on top of WebSocket. Why not just raw WebSocket? WebSocket is very, very low level. I mean, it's practically like using a TCP socket. It's pretty much the same thing. Imagine trying to write a REST application without HTTP. All you get is a TCP socket. It's a hard proposition, right? But that's basically what WebSocket is. HTTP has a lot of built-in things like retries that we take for granted, we don't think about. HTTP gives us things like URLs, it gives us HTTP verbs, it gives us headers, request parameters, a lot of things that we can use in a framework to say, this request should go to this method, and this request we understand what that HTTP request is. With WebSocket, you get a blank message, and you really have no idea what that's about. So this is why the WebSocket protocol itself has built-in mechanism for sub-protocols, meaning that it's pretty much expected that you'll probably use something on top, and then during the handshake, client and server can negotiate which sub-protocol to use, and STOMP is a common protocol which is used in this context. Now, STOMP is basically a messaging protocol that was used originally to connect Ruby and Python to Java, or to, sorry, not Java, but to enterprise message brokers like RabbitMQ and ActiveMQ. And it's very well suited, actually, for this purpose, too, for the web, because it's a much simpler, you don't have to learn everything that AMQP does, you don't have to learn everything that JMS does. It's basically a simplified version of a messaging protocol for pub/sub. This is an example STOMP frame. Obviously, there's a lot more to STOMP, but It's actually relatively straightforward. Here you see that there's a command on the first line that says we're sending a message. On the second line, there's a header, destination. We're expressing what this message is about, who is it for. And there's a content type because we have a body, just like in HTTP. So you can see it's very similar to actually HTTP messages, but it's actually a publish-subscribe messaging protocol. There are constructs for subscribing, and then the server can send messages, getting receipts, things like that we need. And again, a proper introduction would be beyond the scope of this presentation here, but I just wanted to show how once we have something like STOMP, we can do things with it and give you a programming model which is like the @MVC programming model. So for example, back here you see a STOMP client frame, which is for this particular destination, and it has some kind of content and a payload. Here you see a method which is actually designed to handle that message. The app prefix is gone because we use that for routing purposes. That's to be handled by the application. So we're basically handling a message to a destination of greetings, and we're taking a payload which has been converted, JSON, XML, again, similar ideas as what we have with Spring MVC. And actually, you can also have a Spring MVC method in here for doing HTTP GET. There's no need to artificially, even though WebSocket and messaging is a completely different architecture from REST. Make no mistake about that. It's a big step actually to go from REST to WebSocket style messaging. But at the same time, there's no need to artificially separate the functionality for it. For example, if you're writing support for, let's say, managing accounts, you might support both HTTP and WebSocket connections. With a WebSocket connection, you can keep giving updates, whereas with HTTP, you can just send a quick update to do something like a post or a GET. You don't have to be connected the whole time. So there's room for both of these things. It doesn't mean that they can't coexist. And SockJS, that's basically emulation. You're using the exact same WebSocket API. It means you can start writing WebSocket applications today. But underneath what goes on depends on whether the browser actually supports WebSocket or not. This will automatically fall back to HTTP polling, long polling and streaming. And what's nice here is that unlike in Spring MVC where you're actually aware of the polling, you have to manage that. Here it's completely managed transparently. You're treating it as a WebSocket. You're sending messages back and forth, but under the covers it's actually choosing the most suitable protocol for that browser. And SockJS itself is a protocol which came from RabbitMQ originally, but it's now managed by a developer from Major League Soccer. It has a community, it has a number of implementations in different languages, and it supports a very wide range of browsers and versions. It's really going down to the level of, all right, IE 8 and 9, they have AJAX, but they don't do cross-domain AJAX. So we have to do an iframe, and from that iframe, we're going to download the script so that we can then begin sending messages back and forth, dealing with cross-origin requests. So it really goes to great lengths to actually pick the right transport for the right browser. It's sort of best of breed in its category. So that's what we've chosen to do. So SockJS underneath and then STOMP on top. So if you have applications that need this kind of messaging, you can see a lot more on the subject. There's a video available. I think you need to register. It's an organization called Skills Matter. They hosted a conference. The video is still available, so you can see that. But basically, my recommendation would be this. If you have something simple, like Twitter messages or breaking news, that's easy to do with polling. It's not too hard. Even a chat application is not hard. But if you're really moving in the space of collaboration, finance, games, you'll sort of know that this is not a sustainable route. That for that, you'll need something more like WebSocket. And if you need WebSocket, you're going to need a lot of the things that we already provide for that. Okay, we have a few more slides. Well, first of all, how many are using Spring Boot or have tried Spring Boot? Okay, not a lot of hands. I see a few. But basically, the idea, I just want to convey the idea behind Spring Boot because I think it's an important one, and it's sort of another style of writing Spring Web applications these days that is really worth knowing about. So a lot of us in Java development for a long time are used to, basically we have a lot of background, right? We know about the Servlet API, we know about web servers, we know how to configure Tomcat, we know how to configure Jetty, we know WebXML, we know what to do with Spring Web applications, how to configure it all. And we don't do it very often, right? So it doesn't matter, but if you have to start a new web application, how long will it take you to get to a point where you're productive? A long time. Also, if you have new people, say you're hiring coming out of college, they've seen all kinds of things. They've seen Ruby on Rails, they've seen even frameworks in Java that are full stack web frameworks that get you started very quickly. And they're comparing. So a lot of users came to us and pointed to specific examples and said, we know Spring has a lot to offer, but we have these new kids and they really ignore it because they can't see a path into it. Imagine for a new person who doesn't know, to have to learn WebXML, have to learn how to configure, like all of that is so much work, just to get to the point of writing a web application. So this is where Spring Boot comes in, because as you set up applications, there's a lot of choices to be made. You have to pick dependencies. You have to choose how to structure your code. You have to think about how to design a lot of things, how to configure things. And basically, Boot comes along and makes default choices for the 80% of cases, and you're up and running in minutes. That's the end result. And when I say up and running in minutes, I mean you write this code and you add a POM file, and that's it. You do java-jar. You compile that, and you do java-jar. Now think about that for a moment. I didn't say deploy to Tomcat, first of all, or deploy to Jetty. I didn't say write to WebXML. I didn't say any of that. When you do java-jar, it actually puts together all the dependencies for the app. It embeds the server, like Tomcat or Jetty, and puts that all in a single jar so you can do java-jar. You can easily deploy that into a cloud environment, or you can run it locally. And that's really the basic proposition of Spring Boot. It's a completely different way of thinking about writing applications. And I don't want you to walk away thinking, well, this is just a convenience to get started. No, this is actually intended for production. So for example, you can build it as a WAR file as well, and deploy it to WebSphere, WebLogic, or whatnot. It has a lot of built-in metrics. The idea is not just to get started quickly. The idea is that you get to production readiness quickly and not compromise along the way. And what's interesting about that, for a long time, there's been a lot of attempts in Java, not very successful because we don't get that mindset anyway. We say, well, developer is meant to suffer, so we write code. We get to some place, and then hopefully we don't have to repeat it. But the idea here is completely different. It's take me as far as you can, and then start to figure out what I need to customize. And that's where it becomes a key question of what's the customization process. And you'll find that Spring Boot has very interesting approach here. So you see this enable auto configuration that pulls in a lot of things. And if you drill into that annotation, you'll see that it's importing a file. And you look at that file, you see the configuration. It has specific Spring Beans. Now, if you start declaring those Spring Beans yourself, you're taking over the configuration gradually. So it has a very nice model for essentially overriding as little or as much as you want from what it gives you. So again, the idea is get you to production readiness as quickly as possible, and then gradually you take over things that you want to customize. This is a topic which is dear to a lot of applications that are doing REST APIs. How do you do documentation? So again, this is a pretty big topic, but I'll just very quickly say that good REST API documentation cannot be fully automated or generated. The reason for that is because Well, there's a number of reasons, but basically, if you maybe the easiest way to explain it is to look at examples. If you go to Netflix, or if you go to Amazon, or any well-known REST API, if you look at their documentation, what you'll see is not necessarily a full reference like JavaDoc, but what you'll see is guides that kind of walk you through the major scenarios. They kind of take you through what do you do, and this aligns very well with kind of the maturity levels for REST APIs. How many have heard of HeyOS, Hypermedia as the engine of application state? It's a kind of a long acronym, but basically what it means is that just like the way humans browse websites, we don't bookmark everything because then we get 404s after a while. A REST service a client should navigate to what it needs, not go directly at it. And each REST response, server response will contain links to what else is there. And so you will kind of navigate instead of linking directly. So the point is that you don't want to encourage directly linking, but rather you want to show people how to use your API. And that's something that you have to write, just like documentation. But doing that manually, inserting examples, that's also a lot of work. So what if, and this is the idea behind a project called Spring REST Docs. What if you could write real tests using Spring MVC test? How many are familiar with mock MVC and the Spring MVC tests? So it's a great tool for testing Spring MVC applications, a fluent API, very nice way of doing tests. So what if you could do that to write the tests that you want to highlight in your documentation? And then you insert that actual code with real output from the execution of the tests into your documentation. Wouldn't that be nice, right? So you just do like ASCII doctor include statement, and that's pointing to a file, and that file has the actual code and the actual output. That's the idea. And there is a very good webinar by Andy Wilkinson, and Aryan, some of you will know him as a long time contributor to the Spring Framework and Spring MVC. He's in fact a major part of the REST support. He practically wrote it. So when he makes a strong statement, that really means something.
You mean that feature's already there, or something?
Yeah, the Spring REST Docs project is available. Yeah, I don't know the current version number, but it's usable today. You can go and use it and see what it does. And this presentation does a good job of comparing it to other approaches like Swagger. That's another popular tool. All right, so we have just a little bit of time left, and I will talk a little bit about what's coming up, what we're working on at the moment. So take this as forward-looking statements. This is something that may change as we speak, but server-sent events, that's something we already support, that's available in master. And essentially server-sent events is kind of related to the whole topic about long polling and HTTP streaming, but it is based on a HTML standard for generating events from the server to the client. So it's just a variation on long polling where the response is actually formatted into events in specific format, which is determined by the spec. And you can see down here, emitter.send, there's an event name and there's data. Data gets formatted as JSON. I guess another way to explain it is, you can see here we're returning a response entity. And instead of a body, we're giving something called emitter. Now, in another thread, we can start emitting objects. Let's say over the next minute or two, we're going to emit one object, then another object, etc., etc. Instead of rendering the thing itself, you're emitting objects over time. So if you're using server-sent events, you now have basically dedicated response. And you'll see there's a little link on the bottom for the actual ticket which tracks this, and you can watch these tickets or comment on them if you give it a try. HTTP caching is another area where we're spending some time. As some of you know, HTTP 1.1 specs were recently updated so that the old single document was replaced by a number of others that have been improved. There's nothing fundamentally new, but it is true that it's been a while now, so we need to update our HTTP caching support. So we've done a lot of looking through and making sure we're up to the latest and greatest in terms of sending e-tags and last modified headers, and doing things like public and private cache control, for example. So when you're sending cache headers, one of the things you can do is say, are these publicly available resources? Because if you're on a password protected page, you don't want the browser or some proxy to be caching these things because they may be specific to the user. So exposing all of these things in various places. We're also considering an option for a deep e-tag strategy. So as you know, we have a shallow e-tag strategy, which at the end of the response just buffers the whole response and then calculates an e-tag, and then in the end returns a 3 or 4 if nothing's changed. But we're thinking about a deep e-tag strategy, which basically, given a command object, you kind of tell us what's the e-tag for this thing, and then we can decide whether anything has changed or not. If you're interested in that, let me know. It's something we want to be tried with as many different examples as possible. We are planning to add dedicated support for cross-origin requests, and basically this is something which, you know, both Tomcat and JD provide filters that you can do this with today. In fact, I'm sure all of you probably have, if this matters to you, support already. But the point is that Spring MVC has a lot of knowledge about the way that individual methods are mapped. And wouldn't it be nice if you could go on an individual method or controller and say, at cross-origin to say, this method should be okay with these particular hosts. You know, it should be exposed to cross-origin requests. So we're trying to give this kind of fine-grained support. Also, with the course configuration source, we're going to combine that with controller advice. So you can do it not only on a controller, but across controllers. So we're looking at a lot of different options here to expose course in a Spring MVC native way. This is something that we see every now and then that we've decided is a great feature to add. Custom request mapping annotations, or also known as meta annotations. Basically, this is instead of doing request mapping with the produces and consumes for JSON everywhere, what if you could just define a custom annotation? And you can see that we are creating a post JSON annotation, and we're annotating that with request mapping. So effectively, the meaning of that is that when you say post JSON down here, you're effectively saying what's up there. And you can also override it with specific information on post JSON. So that way you can create your own annotations according to your application, and we can work with that too. We're considering an option for JavaScript templating. This has been requested, and there's a very long discussion. Be prepared for that. Under this ticket, you might want to scroll to the bottom, just kind of read backwards. What matters is at the bottom is that the current direction is we're thinking about adding a Nashorn, that's JDK 1.8 support for JavaScript-based view resolver and view contract, which means that you can use something like React.js or some other templating JavaScript engine like Mustache, and you can, instead of using JSPs, for example, you can use that to write your templates. So single page apps, basically what they would do is they would preload, the server would render the HTML using JavaScript on the server side. Then once you're on the client side, because you have the templating technology there, you don't have to ever reload. It's a single page app, right? So that's kind of the idea, to be able to do server-side rendering of what you might be doing with templating on the client side. And this is in many ways very similar to the Groovy markup templating. It's basically templating using another language. On the WebSocket messaging side, we're adding a STOMP client because there aren't any good Java clients available out there, so we've decided to write one. And it's going to be good for testing, if nothing else. It's going to be very useful for that alone, like we did with SockJS Java client in 4.1. It's kind of related, I guess. We are looking at overhauling the Spring Framework reference documentation. It's one of those things where, you know, the code is always refactored and managed carefully, always evolving, but the reference documentation kind of keeps growing. So we're looking at ways to make it better. And one of the things to do is to separate conceptual information from reference documentation, because with concepts you only need to read them once. If you put that in the reference documentation, you have to scroll through that every time. So that's why we're going to be creating topical guides, like for example, what is Spring? You know, the reference really shouldn't be in a position of having to explain what is Spring. It's kind of something you read once, you don't have to see that again. And that's going to be, there's a repository already for that, so you can put a watch if you're interested. Also, if you have ideas about things you would like to see explained, kind of conceptually explained, you know, feel free to make suggestions. You can go to that repository, you can create a ticket. And I think we have a few minutes for questions. I will post the link to the slides, but again, they're going to be on SlideShare. Any questions? Yes?
About that JavaScript caching, the versioning and the hash, when did you say it's been calculated? Every page load? I got distracted.
So if you come to the page for the first time, you have to render links to the JavaScript files. So at that point we're going to get involved, and we provide mechanisms. Actually, it's kind of built into, should be automatic. Basically, if you're using something like the C URL tag, for example, in JSPs, we will automatically recalculate the link for that, which requires calculating a version to insert into the URL. Now, if you come to the page again, we already cached the information. We're not going to compute it twice.
But for how does it know that the page changed now?
Well, so basically the idea is that in production your files don't change. But if you do change them, you can blow the cache. So the cache is actually based on the Spring caching abstraction. There's a cache map manager. And you can get in, for example, with JMX, and you can clear the cache, and it will repopulate it. But in development, you'll probably want to turn that cache off. There are ways that you can do that. You can say there's a true or false flag. So in development, the caching will never happen. Yeah?
You mentioned about Object Builder to map the object back to the JSON response. So would it basically do what Dojo does today, for example?
So the question is about the object mapper, the builder for that. How does it relate to Dojo?
No, I'm asking, does it just map your object to like a JSON response, for example? What is it?
Oh, so the object mapper is basically the way to configure JSON. So for example, if you want to tell JSON to pretty print the JSON, or if you want to do custom serialization, there's a whole bunch of options that typically if you're using JSON, there's a good chance that you're going to customize the object mapper in some way. If you're okay with the defaults, you don't have to do anything. But if you need to modify the object mapper, this builder is very convenient for Java config. Because instead of creating an object mapper with the new, you know, on some level you might say, well, it's Java, why do we need a special builder for it? But the end result is very nice. You know, first because it gives you a nice chained method invocation, but it also encapsulates the way you customize this object mapper. So you can reuse it in different places. Yes?
The controller advice, you said that was kind of supposed to be like a global configuration. Is there a way to refine that more to a subset of controllers, I guess? But
yes, so the question is about the controller advice, and can you refine it to apply to a subset of controllers? Yes, in fact, if you look at the slides, one of them has a few examples of so you can do things like, if you're familiar with the component scan, for example, it has a lot of the same options. You can pick to apply based on the presence of annotation. You can pick based on a package name. You can pick based on type name. So you can really get down very fine-grained. But I don't recommend going too crazy with that, because remember that each time you run, each time we have to invoke a controller method, we have to check, does this controller advice apply or not? So it's a useful mechanism, but keep it pretty coarse-grained. Very coarse-grained. Yeah.
With Spring Boot, can you configure Tomcat directly?
With Spring Boot, can you configure Tomcat directly? Yes. So Depending on where the question comes from, if your question is because in production you already have Tomcat and you have to deploy into that and somebody else is configuring it, you can actually build the application as a war and deploy it as usual, so the configuration is entirely done externally. But there's also, because it runs in embedded mode, there's a whole configuration, auto configuration for the container. So there's a way to customize the embedded container as well. You can even get on the level of extending the classes which initialize Tomcat. So yeah, there are multiple options for doing that.
Which version does it come with? Which Tomcat version?
I can't tell you the exact version at the moment. I believe it's on Tomcat 8. They stay pretty current.
Okay. And we can change it. Can a user change it? Or?
Yeah, so basically, when you take Spring Boot initially, you have a POM, and that POM just says Spring Boot starter web artifact, and that brings in everything you need. You don't have to explicitly spell every dependency, but if you add your own dependency with Tomcat-server or Tomcat-WebSocket with your own version, that will basically, as long as it's a compatible version, like a generation version, but I think should be okay with Tomcat 8. Any other questions? 1, 2. Thank you very much. If you have any questions, let me know.